Hi there, welcome. For those that I've met, hello. For those that I haven't, it's good to meet you. I'm going to present some slides and then I will hand over to Andy Singh and Neil Colleen. Lucky to have Andy this morning. He's very close to having a new baby delivered. We thought he might not arrive today, so he's here as well. So here we go. So we're going to talk about moving data today. It's part of a bigger scheme of data management. But before I do, I thought I'd get into telling you a little bit about Arcitecta, for those that haven't met us before. Arcitecta is a creative software engineering company. We view making software as an art form, but we've got a high focus on engineering and art. Basically, we're makers, software makers. We make everything. Our entire stack is made by us, and that gives us great insight. We make a product called Media Flux. You'll hear that word mentioned a few times today. That really is underpinning the system that is driving the data management itself, but we're going to focus on the data moving and transmission of data. Anyway, that system optimizes data management, the flow, storage costs, enable you to discover your data. It operates at scale. We're used to dealing with billions of objects, petabytes, increasingly tens and hundreds of petabytes of data or more over long periods, potentially decades. So we have some customers that have over 40 years worth of data. And in fact, actually, these systems are replacing traditional archival mechanisms for recording data, pen and paper, tablet, film. These are some of the sort of scales we operate at. We have some customers ingesting 2 to 3 petabytes of new data a month. Some of them then moving it around 4 to 7 petabytes. We've got typically getting into the realm where there are file systems with more than 3 billion files per file system. We aggregate those into much bigger systems. Some of the systems we have over 100 billion bits of metadata, and those are on the small side. We're finding we've got systems with trillions of objects in them. So a complete data system or data management system requires quite a few aspects: the ability to manage the ingestion and acquisition of data, dealing with metadata, so meta, the structured data and the unstructured. Our whole thesis is to combine structured and unstructured data into the one system, so you don't have different systems for your data. It needs to deal with storage virtualization. It's no longer the case that you really want to stick your data in entirely one storage system. We need to be able to virtualize those. But for an end user, it should just look like storage. I need to stick my data somewhere and then get it out later at some point in the time in the future. The underlying storage may have changed since I put it in. So I put it in this year and I get it out in 10 years. So we need to deal with that. A complete system needs to deal with the ingestion and dissemination of data to people. So I'm trying to give a sense that data management is not simply just about a platform that stores data and it's just one application. There's a whole ecosystem here. Discovery, so that is searching for and finding what you need later. I do note that when you get into the realms of dealing with a billion objects or more, it's no longer at human scales. If you get to 100 billion objects or files, it's definitely well and truly at a human scale. So we need aids to help us find what we need. We need to deal with immutability, particularly in the research space. As you make acquisitions, you need to make sure those acquisitions are not changed. In many places, we need to deal with governance. And also in the world of ransomware, we want immutability so that people don't hold our data hostage. A data management system will deal with protocol and data transformation. And I've got evolution next, but generally evolution of formats. So we see the evolution of it. Windows file systems, it used to be CIFS. Now we had SMB2, and we've got SMB3. In 5 years, it's hard to know what protocols we'll have. The data remains the same. We need to be able to put it in and and have it come out later, but it may go in one protocol and come out another. And the format of the data may change. So today we capture in MPEG-2 transport stream, we convert to MPEG-4, H.264, and then a new codec comes out. We need to convert that to MPEG-4, H.265, etc. And this is going to continue for decades. So we need to deal with evolution in terms of the types of data and the structure of that, and the way in which we describe our data, so that we need to evolve with different ontologies. And particularly in the research space, the nature of research is that we're pushing the boundaries, and that means the way in which we describe our world changes. So we need to deal with an evolution in the way in which we describe. And of course, the topic of today is really about the transmission of data. So a complete ecosystem needs to deal with getting data from where it's captured. That is the point of acquisition. We need to then get it to a place where it's curated and stored, so our traditional data management systems. And we then need to, may need to have, and there's a mix of workflows here, they're not all, it's not linear, but we may then wish to move our data to a compute environment, high performance compute, compute on any, it could be anywhere, it doesn't necessarily need to be high performance compute. We need to get our data to the researcher that owns the data, or the researchers that are collaborating in a project. We need to move our data to other systems. So we may be doing some computational analysis at another sister facility or somewhere else. So maybe we're running a project that's got collaborators from multiple institutions or universities. And over time, we would like to share our data with the collaborators, and that should be as simple as possible. All of these are part of a workflow. They might be very simple workflows, point-to-point sharing, or a more complex workflow. I'm going to show some examples of those today. Whatever system we put in place for the transmission of data needs to be reliable. We need to trust that when we've moved data from A to B, that all the data that we had at A has arrived at B unchanged. And that's a simple thing to say, but there are not many systems that you can be absolutely certain that that's happened. When we transmit, we need to be resilient. So, for example, if there are network outages, etc., that the system will pick up, or someone's machine stopped and then restarts. And we need to deal with networks that are varying latencies. So it needs to be fast over networks with high latencies, and the highest latencies on Earth are up to around the sort of 300 millisecond mark. That puts quite a strain on moving things over large distances. And this must be consumable by as many people as possible for non-technical people. So it needs to be very, very simple. We need tools to facilitate the exchange of data, and that's what we're going to look at today. So very simple tools. The kind of patterns of use that we're looking at, so you're sharing data with people, is in a research environment. You've got an external collaborator. They need to be able to, you'd like your collaborator to upload data for you. Now, traditionally what would happen is that you've got a system that you want to make available to a collaborator. You have to put an account. They have to have a local account, or in your Active Directory or LDAP, etc., in order for them to get access to the system to upload, or they put it into a temporary area and then you have to move it out of there. What we're aiming for is the one system that you can securely give someone a token to upload into a place that you designate. They can't see anything else, and they don't need an account in the system. It's trackable, you know who has done it. Same thing for a download. You want to share with someone, you need to be able to send out to one or more or many people, and then allow them to download without local accounts. Another pattern of use we'll look at today is uploading from a shared facility. So you go to get some imaging done at an external facility, or in fact even a shared facility within an organisation, that the facility owner doesn't have access to where your data is going, to your project or anything, but they need to be able to upload data on your behalf, and then you need to make a decision when that data arrives where it should go to and what subsequent workflow processes there should be. So with that, I'll hand over to Andy Singh to take us through from the University of Melbourne's perspective.
Thanks, Jason. We are very excited to be here today to share our experience with you on how we assisting our research community in moving and managing the large data set within our research environment here at the University of Melbourne, Australia. As we all know, moving large amounts of research data is not simple. Often, big data means complex data, and it often involves many difficult considerations, such as the network latency, the privacy requirements, retention obligation, etc. Here at the University of Melbourne, we recognize the need to provide an integrated workflow environment for our researchers to bring coherence to how data are collected and distributed. From the many throughput research instruments that have been employed here at the university, coherence is of utmost importance when it comes to storing and dispatching data to our researchers and their collaborators. In today's presentation, we will share some light on the challenges and solutions involved with moving big data within the diverse and multidisciplinary research environment at the University of Melbourne. So I will start our presentation with a brief explanation of who we are and what role is in helping our research community. Then I will describe the challenges that we face, which is likely applicable to most, if not all, the large research institutions around the world, and the strategy we developed in addressing those problems. My colleague Neil will then take over and talk a little bit more about the development of the data mover and the rationale behind the approach we took to tackle the aforementioned challenges. There will also be a short clip of data mover in action before we share with you on what we have learned during this journey, particularly working with the Arcitecta team and where we would like to take this from here. So Research Computing Services is a team of around 40 IT professionals. Our role is to provide specialized technical support and IT infrastructure as a leading driver of research and innovation for the University of Melbourne and its affiliated research community. Currently, we operate several core services, including Melbourne Research Cloud, a 24/7 infrastructure as a service cloud virtualization platform that is based on OpenStack and SAP technologies. This consists of over 25,000 CPU cores. There is also an in-house high-performance computing cluster with 6,000 physical cores plus 360 GPUs that comes with a specialized high memory configuration. We also perform and operate a dedicated research data management platform, which is powered by MediaFlux, and a number of alternative storage infrastructures, such as NetApp NAS, S3 Object Storage, and AWS Glacier. At the moment, there is over 18 petabytes of raw usable storage, of which 14 petabytes has been consumed. MediaFlux is hosting around 5.5 petabytes of those research data. Additionally, RCS also provide publishing and showcasing services such as Figshare and Omeka as well. Just to provide some context about research at Melbourne University, the university receives the equivalent of $400 million in annual research income. There are 26,000 graduate students and over 8,500 active researchers. Collectively, they are working on over 3,500 plus funded research projects. So what are the challenges? We have always known that the university has a large number of research instruments. For example, micro-CT scanners, mass spectrometers, cryo-EM microscopes. Combined, they generate enormous amounts of data. But we didn't really have any concrete intel on just how much data are being generated, how researchers get their data back to their workspace and share with their collaborators. And perhaps the most important things are what necessary security and other regulatory requirements are needed. In 2017, we undertook an analysis of all the university's instrument platforms to try and understand the scale of these issues. This analysis targets 4 main areas. First, how were data being dispatched to the users? Second, were there any long-term repository being utilized? Third, how were the data being processed? And finally, who was supporting this process at what cost? Based on the outcome of this analysis in 2017, the university executed a program of work in 2019 focusing on handling data from instruments, with the primary consideration being creating a framework to support data flow from instruments to centralized storage with an optimal process. And the results were interesting. We found that the data generated by newer instruments are becoming increasingly large. For example, the new generation of the cryo-EM microscope can produce up to 10 to 15 terabytes a day. It is estimated that 2 petabytes of data will be produced collectively by all instruments at the university. There exists a high volume and many variety of instruments. Currently, University of Melbourne has over 140 instruments and continuing to grow. We also noted that there is no standard workflow for delivering, sharing, and storing data among instruments, and many users have different usage patterns. This also raised the question of the overall maturity of data handling across the university. Many instrument operators also spend a lot of time on handling data rather than doing research, which is not ideal. And we have also learned that dispatching big data to end user is challenging. It is also a very expensive exercise to support multiple localized data transfer implementations. Last but not least, it is not easy to meet the compliance requirement of funding agency. For example, the security questions, the retention obligation, etc. So in response, we developed a strategy to address these challenges. And our aim is to consolidate the many identified data handling implementation into a small set of reusable patterns that could be appropriately supported by a scalable and sustainable framework. And this is where the data mover comes in. Now, I will pass over to my colleague Neil, and he will take you through the final details of the data mover, how it works, and the rationale behind our approach.
Thanks, Andy. So why did we take the approach of working with MediaFlux to address these challenges? Well, firstly, here at the University of Melbourne, we've worked with Arcitecta and MediaFlux for over a decade. So it's a well-established platform at the University of Melbourne. And over that time, we have had many successful collaborations with Arcitecta. So Arcitecta is a trusted partner, and this is a very important component of any collaborative work that you choose to undertake. So we already had some quite significant experience utilizing MediaFlux, in particular with instruments and handling data, and of course, in more recent times, some of that data is quite big. And the sorts of instruments that we worked with over the years are imaging scanners, MRI scanners, PET scanners, gene sequencers, optical and electron microscopes, cytometry devices, and so on. And so what we did was, following the audit that Andy talked about, we developed a project of work called the Instrument Integration Project, which was embedded within a larger university project to uplift research computing infrastructure. And that included a very strong engagement process with our stakeholders. So they were a part of the journey. But we chose to continue our work with MediaFlux and take an incremental approach to build on our experience and the knowledge to create what became, with Arcitecta, the data mover. And I think this is a very important component in that we had already developed some in-house capabilities, which were early versions, if you like, of some of the componentry that turned into the data mover. So we weren't doing this cold. We had a pretty good idea of what we wanted to achieve and how to build some new patterns and to ease the process for both the operators of instruments and the consumers of the data, the end users. Also, of course, as we all know, changing technology stacks is incredibly expensive. The devil is in the detail with any piece of software, and it does take many years to get to know all the details of a particular platform to leverage it optimally. Sticking with MediaFlux, of course, also meant an easier transition for our existing MediaFlux users. And keeping in mind the overall strategy, which was to raise all of the instrument platforms up a level, if possible, to sort of the base level, to at least have their data stored centrally. We decided to begin with a manual approach, in the sense that the data mover is a tool that you manually interact with the intent always to automate processes in a subsequent phase. You've got to walk before you can run, and when you're trying to work across the entire university, if you bite off too much, then you'll make that process less tractable. So the data mover itself, I'll just mention a few attributes of it before showing you a workflow picture. And these really pick up the threads that Jason was alluding to. So the data mover is a tool built by Arcitecta in collaboration with us that uses the HTTPS protocol, so it's secure. It can be trusted because it does integrity checks. It makes sure that the data that you uploaded arrives at the other end. It's resilient because it's restartable, and it's something we've seen over the years, particularly when we have end users outside the university, is that the networks are often quite unreliable. And we all know the pain of starting a big download only to have it fail in the middle and have to start again. So the data mover, one of its key requirements was that it was restartable and resilient to network issues. It streams data from opaque manifests. So this is a part of the anonymous work that Jason alluded to, that the end users can upload data and download data, but they do it opaquely. There are no containers, so that when you stream the data, you don't first make a container and pack it and then have to unpack it. So it's efficient from that perspective. It can work in parallel to take advantage of network bandwidth. And there are three basic workflows. There's the generic anonymous upload, so you can be given a token and that's you upload some data into MediaFlux for somebody else. Anonymous download, so you can be given a token that lets you download data from MediaFlux. And then on top of those basic capabilities, we built a specialized and configurable instrument workflow. And I'll show that workflow in a moment. The data mover has a simple GUI, and it also has a command line interface as well. And this is very important because even today, often server environments don't have windowing systems, and so it's a bit pointless to have a graphical tool and try to use it in an environment where there's no windowing. So both of those components are there. And the GUI layout is configurable to some degree through XML structures. There's support for macOS, Windows 10 officially, but it does actually also work on Windows 7 and Linux, and it comes with installer packages. Another nice feature of the data mover is that it auto updates itself. So when there's a new version available, you can get that automatically. Right. So this is the basic instrument workflow, and you'll see this again when we run the demonstration. Hopefully it will consolidate. Just focus for the moment on the middle of the diagram, and that's MediaFlux. So for every instrument that we're going to try to handle, we provision some resources inside MediaFlux, and we'll call that the instrument project. It's a place to put the data. And the instrument project has a team of people that can directly access it, and that team is drawn from the instrument facility staff. Only they have access to the instrument project. End users don't have direct access. The end user themselves may also have a user project of their own inside MediaFlux. So having first provisioned some resources inside MediaFlux, then what we do is deploy the data mover tool itself into the instrument acquisition host. So that's over there on the left-hand side. And we configure the data mover tool with a token which enables it to upload only to the instrument project. And anybody that can access and execute the data mover tool on that host, for example, instrument staff or trained power users, will therefore be able to upload data into the instrument project. So to actually execute the workflow, the end user or the operator, whoever it is, simply runs the data mover GUI. They select the data that they want to upload, and they enter the email address of the end user for whom the data are destined, and click upload. And that's all there is to it to initiate the workflow. The data will be uploaded to the instrument project, and then a configurable post-upload workflow kicks off. And this is a really terrific part of this workflow, and it's configurable in the sense that you, the person operating the MediaFlux service, can configure that workflow, that post-upload workflow, to make sense for your environment. And so this is what we've done. We've configured it as follows. Once the data have been uploaded, firstly, we actually generate a little manifest asset which has information about the upload and stick some metadata onto that asset so that the upload can be found through keywords and things like that later on. And then an email is dispatched to the end user. Of course, that's the email address that was entered when you uploaded the data in the data mover. And in that email, there'll be up to 3 links. The first one, and they're all configurable which ones you choose to have. The first one is a direct download link. So that is a container, and of course that might be appropriate if the instrument data you're producing is quite small. The workflow doesn't mean you have to use it only with big data. The second kind of link is a download link which will use the data mover tool itself to download the data. So this is the one that will stream it directly to your local storage. It's a bit like a Zoom link. So once you click on that link, if the data mover is installed, it will simply pop up the interface and invite you to click download. If it's not installed, it will take you through an installer process to install the data mover and then execute the download. And then the third kind of link you get is a user interaction link, we call it. And it's a link that when you click on simply opens up a small web interface. You'll get that link if you have your own MediaFlux project and you have permission to write into it. And so once you authenticate to the MediaFlux system, you'll then be invited to pick your project. You may have more than one, and copy the data to it. And just to emphasize, in both cases, download or copying, the end user doesn't have direct access to the instrument project. It's all handled through the infrastructure. So this workflow ticks a few boxes, and as we all know, ticking boxes is very important. It ticks the box of helping operators dispatch data to their end users and discharge their responsibilities for data handling. And as Andy mentioned, we saw that a lot of operators were spending a lot of time with ad hoc processes to move data around. This really simplifies things for them enormously. It helps the end users by making it easy to get their data and to get their data reliably. And it helps the university be able to leverage its investments by better management and tracking of the data that its instruments are acquiring. So at this point, I will hand back to Jason and we'll have the demonstration.
Thanks, Neil. Just give me a moment and I'll bring that up.
The data mover is an application in the MediaFlux ecosystem that can be used to efficiently and safely exchange data with MediaFlux, and it can be used in a wide variety of workflows. Today, we're going to demonstrate two real-world implementations used by the University of Melbourne. First, a simple user-to-user workflow. In this situation, the user wants to share a location with an external party, allowing them to download selected content from MediaFlux, or upload content to a designated MediaFlux location. Here, I'm logging into the MediaFlux Explorer application, another component in the MediaFlux ecosystem, as a user that represents a researcher who has access to a single project, ending in .38. We're going to create a download share for an existing namespace under that project. An upload share could also be created here instead in a similar fashion if desired. A share needs a name and can have a description which will be displayed in the data mover client. Additional controls can be applied, such as validity periods or a password, which when provided out of band can be used to protect against unauthorized use of the share. An invitation can also be sent via email by entering the details here, but we'll just grab a copy of the share URL directly, as we are acting as the recipient of the link as well. The link generated for the share allows the recipient to download and install the data mover client for their platform, which I've done already. If the client is detected, the user is prompted to open it directly from their browser. When the data mover client opens, a dialog displays the information about the share. This one allows us to download data, shows us the number of files and its size, as well as other information that was entered when the share was created. The consumer of the share can also select where the content will be downloaded to, and hitting download will start the process. Note that if the target directory for the download already exists, the user will be prompted with how they want to deal with conflicts. While the download is in progress, it can be paused, and even if the data mover is closed, it can be resumed when it's reopened. Completed transfers can be seen on the completed section, where the location can be accessed directly, and a CSV report can be obtained. When no longer required, these can be cleaned up. Now we'll take a look at a more sophisticated workflow that includes custom workflow steps. This scenario demonstrates the use of the data mover to allow an operator to upload data from an instrument workstation to an archive on the behalf of a researcher, and kick off post-upload steps that will allow the researcher to obtain a copy of the data in different ways. In this solution, the data mover is deployed to the instrument workstation or a host adjacent to it, and is configured with the token of an upload share, which will request information about the researcher for whom the instrument operator is capturing data. The data mover client can be operated by anyone with access to the instrument to upload data to MediaFlux and dispatch it to the researcher. The upload share is also configured to launch a series of post-upload steps. In this example, the uploaded data will be stored in the instruments project in the namespace unique to the upload, along with a manifest. Once the upload is complete, the researcher receives an email notification with links that allow them to download the content or transfer it to their project in MediaFlux. The content uploaded to MediaFlux can be captured to a long-term archive or a transient project. If the instrument project is transient, then an automation process can be used to generate notifications to the operator when the lifetime of the download links expire, to prompt the operator to destroy the uploaded content if desired. Before we upload any data, I'm going to log into a separate MediaFlux Explorer instance using the credentials of an operator who has access to the facility's project archive under which the data mover will upload files. As you can see, we have a project ending in .37, which contains a namespace called Data Mover Uploads, under which a pre-configured upload share will be creating assets. For this demonstration, the data mover has been configured with a token of the share that I just mentioned. As you can see, when the client is opened and a new task is created, an upload share screen suited to the facility is immediately displayed. Note that this share captures a name for the upload, which will be used as part of the namespace into which the uploaded content will be placed. We'll see this in a moment. A set of keywords can also be entered to aid in identifying and searching for the upload in the future. Most importantly, an email address of the party that the data is being captured for can be entered so that they can be notified when the upload is complete. At this point, the operator can select the directory or files from the instrument workstation that should be uploaded and can initiate the upload. It's probably worth noting here that the data mover can also run in a CLI mode from the command line, allowing for use in non-graphical environments as well as scripted scenarios. As you can see, a new namespace containing the name specified in the data mover form has been created to contain the uploaded data. This is a convention and is configurable. Once the upload completes, an email with information about the uploaded content and links to download or transfer it to another project in MediaFlux is sent to the address specified when the upload was initiated. Here's an example. The first link allows the content to be downloaded as a simple archive via the browser. The second is for an automatically generated download share that can be used with the data mover to reliably retrieve the data. This is identical to the download demonstrated earlier, so I'll skip it here. The final link is to a user interaction, another element of the MediaFlux ecosystem. A user interaction link is only included in the event that the email address of the recipient corresponds with a MediaFlux user configured with a writable project. When a user interaction link is opened, the recipient is required to authenticate using their MediaFlux credentials. I'll log in as the user that represents the researcher for this demo. This interaction simply asks the recipient to select the destination project to which the content that is currently in the facility archive should be copied. This user has only one project, so we'll select it and initiate the copy. Once the copy is complete, another email will be sent to both the recipient and the operator confirming that the uploaded data was copied. If we switch back to the MediaFlux Explorer, where we're logged in as the recipient of the data, we can see that the data has been transferred to the project as expected.
Okay, so thank you, Simon. I'll just hand back to Neil to quickly summarise where we're up to, what we're seeing, and then we'll take questions.
Thanks, Jason. Yeah, so just to recap, the data mover is a simple to operate, self-installing manual data movement tool with both a graphical and a command line interface. It's cross-platform, supporting macOS, Windows 10 and 7, and Linux. It's secure, HTTPS protocol. It's scalable because it can operate in parallel and streams data directly. And it's resilient in the face of network outages or network latency issues. There are three basic workflows: anonymous upload and anonymous downloads that you can use to share data with collaborators, and the specialized instrument upload and dispatch, configurable dispatch workflow. And an important thing to note with this workflow is that it handles both internal and external users. And at the University of Melbourne, many of the instrument platforms are fee for service and part of bigger national networks and have their user base drawn from actually all over the globe. And so being able to get data to external users is a key part of this workflow, and that's often a sticking point for other capabilities. And of course, the way we're doing that is by giving them a data mover download shareable to stream the data to their storage. And under those situations, we don't hold their data long term. What's in the future for us? More deployments. So we began deploying to instruments late in 2020, and we've done we did 20 instruments by the end of Q1 in 2021. So we'll continue our work deploying the data mover to more instruments, and we're pushing into 3 major platforms at the moment. We have a small phase 2 development program in hand, and it will largely focus on new features to improve usability and scalability. And I'll mention it now, I guess. One of the things we want to do is integrate with multi-factor authentication. So as Jason mentioned, in the kind of modern world, we have to be more and more careful about how we manage our resources and information. And there's a new capability coming in the MediaFlux ecosystem called the MediaFlux Pocket, which is a mobile phone app, which includes notification capability. And so we intend to work with Arcitecta to integrate that so that when you get your download share, just like when you authenticate, you can get a notification on your MediaFlux Pocket saying, was this really you? And you can authorize the download. Tighter integration with other services is something we want to and are working on. So for example, the workflow you've seen uploads the data straight away from the acquisition computer to MediaFlux. But that's not the only workflow that's of relevance. And in particular, quite a number of instruments do pre-processing work. And the one that we're working with at the moment is our good friend, the cryogenic electron microscope, which you heard a lot about. They actually need to pre-process the data in quasi-real time and feed that information back to the acquisition system to improve the acquisition as they go. So the idea there is that the data would be streamed not straight to MediaFlux, but to perhaps an HPC or a cloud environment where the GPU processors are available to do the pre-processing. And thereafter, once the data have been acquired and pre-processed appropriately, it will be uploaded with the data mover into MediaFlux. It doesn't matter where the data mover runs, of course, it can run any host that's of a supported operating system. And the really big topic, I think, is automation. So you've seen so far we've been working with a manual upload process, but a lot of, again, instruments acquire lots of data, small data all the time. And a manual process isn't necessarily the right one for them. So the university has picked an instrument booking software called iLab, which is deploying top-down across all of the instrument platforms. And so this is where users will book an acquisition on an instrument where it'll be integrated with billing systems and all sorts of stuff. So that's an opportunity for us to integrate and automate. And in fact, we have one group that's already done this. They've utilized the command line interface of the data mover and fetched information from iLab and kicked off an automated upload through the command line interface. That's not the only way to do automation, but it's quite a powerful one. So we'll be kicking off some work to look at automating these processes. And that also, by integrating with systems such as iLab, that offers you the opportunity to extract richer metadata. So what you've seen so far is very much about just moving data around. But as Jason showed in his early slide, there's a whole ecosystem of things that you need to keep track of in managing data, and that includes metadata. And the most obvious place that would come from would be from some kind of lab admin or instrument booking system. Lessons learned. Did we learn some lessons? We did. Despite the apparent simplicity of the data mover and the simplicity of the workflow conceptually, its development was not straightforward. And this was a major piece of work for Arcitecta, who of course did the development. We were the testers and the conceivers and the partners. But it was not a trivial piece of work. And perhaps we, despite our, I don't know, 40, 50 years of joint experience, we underestimated the effort. So the learning, which we seem to keep learning, is to be a little more conservative in project timelines. And of course, project timelines are hard to keep to meet for various reasons. And involving our stakeholders was sometimes hard to get their time because firstly, we had a pandemic. So we were all learning to work from home and deal with that, but they also continue to operate their instruments and they're all very busy doing their own thing. So getting a hold of stakeholders in a timely fashion was sometimes a bit harder than we expected. Because we involved our end user stakeholders all the way through the process, there were no bad surprises or any surprises really, or serious scope creep from our joint perspective. And this was very important. And we put a lot of effort into the stakeholder engagement to really keep them in the loop. And they were terrific as well. So they involved themselves, came to all the workshops, and always gave us useful feedback. The final capability of the data mover has perhaps more flexibility than we'd originally envisaged in the requirements. So the learning there is, don't be too precise, because when you work with an organization like Arcitecta, in my experience over more than a decade, the way it works is that you don't just say, build me this, and they build you that. You have a conversation about what it is you're trying to achieve, what is the capability you want to develop. And so of course you write down requirements, those that costings can be made and all that kind of stuff. But ultimately it's actually a journey together, a true collaboration. And so it meant that the implementation in the end, through those conversations and continual joint engagement, gave us this flexible workflow that we can actually reuse in all sorts of ways that we didn't really conceive of. And finally, operationalizing it was quite straightforward. I mean, we have a lot of experience, of course, operating MediaFlux and MediaFlux clients. But because we knew what we were getting, because we'd been so tightly involved in the process, deploying it to instruments and then supporting the processes that came from it was relatively straightforward for us. So really the only thing that stops us deploying it faster is just getting access to people and their time to deploy it. And at that point, I will stop sharing and hand back to Arcitecta.
Thanks, Neil. At this point, actually, we'll take questions if people have them, and we'll attempt to answer them. So if you've got a question, just pop it into the Q&A. I see there's one in there now. The demo shows a user interaction being used when the data mover completes an upload. Could a workflow include multiple interactions? The answer is yes, because the workflow at the end is it's connected with a service in the system. So the interaction kicks off a service. Those services can kick off other interactions. So that interaction framework that generates that user interface is a part of the system itself. You don't need the data mover to kick those off. You can kick them off as independent processes. So for example, if you wanted someone to approve the deletion of something, they could get an interaction. So we can chain these together in a set of steps. In fact, they could, in theory, go out in parallel as well, or connect up to a more standard workflow process or engine.
I could just add one comment to that as well, and that we've been thinking about other places that you might need to dispatch the data to. So you could, for example, instead of copying it to your MediaFlux project, you might send it to an SCP server. There are SCP services within MediaFlux, and so the user would simply authenticate firstly to MediaFlux. They would provide the credential for their endpoint SCP and then send the data there. The framework gives you lots of flexibility to think about how you want to move data around.
Are there any other questions? Here's one. What does it cost for collaborators? The answer to that is it doesn't cost anything for the collaborators themselves. So anyone with one of our software MediaFlux installed, it's free to use for any collaborators around the globe, and all they need to do is click on the link as we saw, and it will automatically download and install the software they need. So the objective is to enable sharing and make that easier. And actually, an even bigger objective there is such that you don't need to copy data out of your repository and put it up into some cloud sharing service or some external service. It's served directly from the core system, which is housing the data. Now it's secure, as we saw, because those tokens are one-time generated and they're anonymous and unique, and the end user is blind to the location that the data is being uploaded to or where they're receiving that data. So no cost for the end user. Yes, that's a very good question. So I've been asked, since the data mover software is being downloaded by users, is there an easy way for users to get updates? One of the aspects of this that we concentrated on was making sure that updates are very easy to deploy. So what happens is once the user has downloaded the software, so they install it into their environment, the software itself, every time it starts, we go and check to see whether there are any updates. And from within the application, it'll notify the user that there's an update and they can choose to deploy that or not. And it will download an update and happens very seamlessly. It's not like a lot of software. It happens in situ, so the application will come down and launch. And we make a decision of when we publish those updates. There's a global software server that sends those updates out. So the process is a once-off installation. So you go through the installation and then it's self-updating. Got another question here. So the hosting entity operates and manages a secure private cloud that enables the sharing with collaborators. Yes, that is true. So our system houses the data and you choose to make that data available to collaborators and partners. You don't need another service to do that. And provided that there is a network pathway to the wider world, which most of these systems do, and that's enhanced through the use of multi-factor. If you want to ensure that we've got no people coming in that shouldn't be there, as well as other defensive mechanisms that we have built in to detect attempts to break in, etc. But basically the idea is if you've got a requirement to manage data, you've got a data hosting environment, you've got our software, you can use that same system to share data with your collaborators. That is, they can download or upload. You don't need a third-party hosting environment. And as Neil showed, or sorry, Simon showed in the video, you can have a standard download link, and that showed the data being downloaded in a container, a zip file, or gzip. So that's what Neil referred to as a container. Or you use the data mover to actually stream the data down for you, and it unpacks it on the fly, or it's all there ready to go. Yeah, so you don't need it. It's essentially a private cloud. Got another question here. What controls are there on sharing? I think you might have seen a little bit in the demo video that Simon put together that indicated you can control the dates of validity. There are all sorts of controls in here because we want to make sure that you're only sharing with those that need to be shared with. So there are controls underneath that are not yet available in that in the GUI because there's some quite complex ones. But you can restrict the shareable tokens to IP address ranges. You can restrict them, as we saw, to dates that they can be used. You can restrict them to a number of times of use. So you can make them specifically for an individual. So once that individual consumes it, the token is automatically destroyed. Or you can make the shareables available for multiple users or for time limited. So which is, as much as you can, you narrow the window to the smallest possible, and that improves the overall security yet again. Okay, if there are no more questions, I might hand over to Anna to wrap up. And thank you very much for attending. Thank you.
Yes, thanks everybody for attending. We'd love to hear from you. So if you've got any further questions or if you have any feedback on the session from today, visit our website, arcitecta.com. Just again, thank you very much to Dr. Andy Seng, Mr. Jason Laurie, and Dr. Neil Killeen. Thank you.